Hello scholars. Go ahead and work on the do now. You can pause the video. When you're ready, you can just play it so we can go over it. Okay, so I see that the function here is x times sine of x. When I'm multiplying two functions and I need the derivative, I need to use the product rule. So I'm going to split this up to f into g. And I need f prime and g prime. Putting it together, I get f prime g plus f g prime, which is 1 times sine x plus x times cosine x. And if I want to make that simpler looking, it'll be sine x plus x cosine of x. Okay, so today, first thing we're going to review is implicit differentiation. The main thing with implicit differentiation is we need to remember that the derivative of y will be dy over dx. Okay, so number 20 says let y equals f of x, let it be a twice differentiable function such that f of 1 equals 2. That just means x comma y is equal to 1 comma 2. I have dy over dx is y to the third power plus 3. And I need to get the second derivative of y. Okay, well, that's fine. To get the second derivative, I just need to take the derivative of dy over dx. So that's going to be 3y to the second power using the power rule. However, we have to remember that we took the derivative of y and we have to multiply it by dy over dx. Plus 3. Well, 3 is a number, so that's going to be 0. This is our second derivative. Now we are not done because the question says, what is the value of the second derivative at x equals 1? A few things. We know that when x equals 1, y has to be 2. Take a moment to understand how I got this information and where I got this information. Okay, so now I can just see what I can plug in. I have 3. I need to plug in something for y, and I need to plug in something for dy over dx. Well, for y, I know it's 2, so I can just write 2. For dy over dx, this is a little bit trickier because there's no number given to us to plug in for dy over dx. So I need you to take a moment, look at what we have, and figure out how we can solve what dy over dx should be. Well, we have to remember that the formula for dy over dx is y to the third plus 3. We can simply plug in 2 in here and find the exact value of dy over dx. Okay, so 11 goes here. So that becomes 3 times 4 times 11 becomes 12 times 11, which will give us 132. All right, next problem. I'm going to use a different color here. Okay, they give us sine xy equals x. And they want us to find the derivative. A few things. We see that there's an x times y here. So we're going to have to use the chain rule. And since there's a y in the function, we're going to have to use the implicit differentiation. All right, let's get to work. The derivative of sine is cosine. However, I need to multiply this by the derivative of the function inside the parentheses, x times y. x times y. I need to use the product rule. So I'm going to split it up. Get f prime and g prime. Put it back together. Make it simpler looking. And this is what I'm going to have to multiply to cosine xy. So again, we use the chain rule and we use implicit differentiation here. Equals, the derivative of x is 1. Okay, so the thing here is we need to get dy over dx by itself. Okay, so we need to move everything. All right, so I'm going to divide by cosine xy. I'm left with y plus x dy over dx equals 1 over cosine xy. Subtract y. Divide by x. So I have dy over dx equals 1 over cosine xy minus y all over x. Now my job is to find a match. Okay, so I'm going to go through elimination so it helps me. So A doesn't look anything like what I have. B, nope. C, nope. Okay, so now I'm thinking, okay, I need to make it look like one of the multiple choice options. Okay, so one thing you can do is multiply top and bottom with cosine xy, okay, which I found right here, this denominator. So I can distribute it to top and bottom, which will give me, I'm going to move this whole thing over here, cosine xy times 1 over cosine xy will cancel. I'm left with 1 minus y times cosine xy is y cosine xy divided by x times cosine xy is x cosine xy. This is dy over dx. Number 27. So we have a long function e to the xy minus y squared equals e minus 4. And they gave us an x equals 1/2 and y equals 2, so we know that's 1/2 comma 2. And they need us to get dy over dx. Okay, let's get to work. So I'm going to rewrite e to the xy minus y squared equals e minus 4. We need to get the derivative one by one. So e to the xy will be e to the xy times the derivative of xy. So I'm going to do the product rule. F prime and g prime. Put them together. 1 times y plus x dy dx. Make it simpler. So that's what I'm going to multiply right here. Minus integral derivative of y squared, which is 2y times dy over dx, equals e minus 4. I need you to take a moment and remember that e is a constant. E is a number. So e minus 4, the derivative of that is 0. Okay, so we're almost there. We need to get dy over dx by itself. But we also know that they give us x equals 1/2 and y equals 2. We wrote that down. We said 1/2 comma 2. So we can go ahead and plug this in to make our equation easier. So e to the 1/2 times 2 times 2 plus 1/2 dy over dx
minus 2 times 2 dy over dx equals 0. Okay, so 1/2 times 2 will be just 1, so I'm left with e. Now I cannot combine 2 plus 1/2 because 1/2 has dy over dx attached to it, and 2 does not. They're not like terms. So I know you're going to be tempted to add them together. Do not. To keep them separate. Minus 2 times dy dx will be 4 dy over dx. I can distribute the e. Okay, I can subtract 2e from both sides. I can factor out a dy over dx and divide it by 1/2 e minus 4, 1/2 e minus 4. So I know that dy over dx should be negative 2e divided by 1/2 e minus 4. So now my job is to figure out which one here matches my answer. Great, so let's go through the whole process. I'm gonna erase a and b. It has nothing alike with what I have, as well as e. Okay, so now I'm down to 2 options. I'm going to see what I can do. There's a 1/2 here, so what I can do is get rid of that by multiplying top and bottom by 2. I'll get negative 4e over, distribute the 2, e minus 8. So I'm so close, I'm so close, I'm so close. I know it has to look like, it's not going to be d, it has to look like c. Now you're wondering why they're the same, okay? What you can do is multiply by negative 1. You're going to get 4e over negative e plus 8, which is equal to 4e over 8 minus e, which matches exactly c. Okay, so I'm going to pause here. That's some review for implicit differentiation. Use your notes, use your Barron's book to review more of this. Okay, so when you're ready, watch the next video so we can review inverses.